target 7.6. We're now completely flipping gears, okay? So 7, the first half of KC7 was all about how polynomials look, their graphs, right? Moving them around. Now we're going to get into more of the equation part of it, okay? So our first learning objective is I can divide polynomials using long division by applying the rules of integer long division. So the first thing we're going to do is remember what long division is. This is something you learned probably around 4th grade, right? And now we're going to apply this thing we learned in 4th grade into what we're doing now with polynomials, okay? So that's why we're going to do our first example, going all the way back to elementary school. So I want to divide 3,453 divided by 13. And I can do this without a calculator. Okay. So I'm going to take 3,453. What I divide goes in the house. 13 goes outside the house. So this is in the house. Our steps for long division are divide, multiply, subtract, and then bring down. I choose to pick. Bring down. Okay. Bring down and repeat. So these are our steps. So our first is divide. So I'm going to take, this is 2 numbers, so I'm going to take my first 2 numbers. I'm going to think about how many times 13 goes into 34, okay? How many times it evenly goes into 34. Well, 13 goes into 34. 13 is 1, 26 is 2, 3 would be 39, and that would be over. So it evenly goes in 2 times. My next step is to multiply. 2 times 13 is 26. Okay, this is what I was saying, I don't know, a lot last unit, or last half of the unit, that lining and organization is very important. This 2 is right under this 3. This 6 is right under that 4. Everything is lined up. Ooh, let's use the right color. I'm going to subtract them. So I have 34 minus 26. Well, I get 4 minus 6. Oh. Right? 14 minus 6 is 8. 2 minus 2 is just nothing. So we don't. Right? So 34 minus 26 is 8. And then our last step is to bring down. Okay. Now again, same thing. I have my first 2 numbers here. 13 is going into, how many times does 13 go into 85? I'm just going to start counting up by 13. 13, 26, 39, 52, 65, 70, 65, 78. I can do this. The next one would be 91, I believe. So doesn't work. So I counted 6. Just keeping track on my hands. Okay, so you can kind of count up that way. So it's going to be, 13 is going to evenly go in 6 times. So now I'm going to multiply. Well, 6 times 3 is 18. We get another 1. 6 times 1 is 6, plus that 1 is 7. Going to subtract. So I get, gotta borrow. 15 minus 8 is 7. 7 minus 7 is nothing. Oh, I used the wrong color for our multiply step. That's why it looks weird. Just changing the color. And then I have to bring down. Now, how many times does 13 go into this 73? Well, we already knew 6 times hit us to 78, and that's already over that. So I'm going to guess it's 5 times. 5 times 3 is 15. Again, it has a 1 carried. 5 times 1 is 5, plus 1 is 6. Subtract. Again. Borrow 1. 13 minus 5 is 8 and nothing. Okay. Now 13 can't go into 8, and this becomes our remainder. Okay? So 3,453 divided by 13 is 265 with a remainder of 8. We could also write this as 265 and 8/13. Fancy. Okay? Maybe we remember doing this when we were little. Possibly. Okay? So now let's look at how this is going to help us with polynomial long division. Okay. So polynomial long division is dividing two polynomials. Okay. If, such as p of x divided by q of x, if the degree of p of x is greater than or equal to the degree of q of x, we follow very similar steps. Okay, so step 1, divide first term of p of x by first term of q of x. Okay, so it's the first term divided by first term. Lots of examples, don't worry. Step 2, right? Before it was multiply. We're going to do the same thing. Multiply step 1, right? Whatever you got for step 1 by q of x. Whole expression. Okay, so before in step 1 it was just the first term of it, and now it's the whole expression. So that's a little bit weird. Step 3, subtract p of x minus whatever you just got in step 2. And again, if you line everything else up, it makes sense a lot more. Okay. Step 4, bring down remaining terms. And repeat. Okay, so this works, we repeat as long as the degree of the one is greater than or equal to the degree of the other. As soon as our first one is smaller degree, we're done and we have a remainder. So we'll see how that works, okay? So it's the same steps, it's just a slightly different way of using them. Okay, so this goes inside our house. Our house has to have enough room on top where we can write things. So I have 2x squared plus 3x minus 35. And on the outside, I have x plus 5. My first step is to take 2x squared and divide it by x. I'm going to do that over here. Well, the first thing I notice is that this is technically a 1. 2 divided by 1 is 2. X squared divided by x, well, I'm going to rewrite this x squared as x times x. Hey, look, this x and this x cancel, so I'm just left with 2x. Okay, so if you're ever confused, rewrite your exponents as just how many x's you have and start canceling. Okay, it makes it a little easier. This, now, here's where we want to line things up. This 2x is going to go in my x spot. My next step is to multiply. Multiply my what I just got in step 1, this 2x, by all of this thing. Okay, so I have to do 2x times x plus 5. Well, that's 2x squared plus 10x. Again, lining everything up. My x squared goes under my x squared, plus 10x goes under my 3x. My step 3 is to subtract. What I do with subtraction is just like what we did in subtraction in our little mini unit, right? I'm going to change the sign. Let's put that change all signs. Okay. What does that do? Well, 2x squared minus 2x squared goes away. That's what we want. 3x minus 10x is negative 7x. And then I'm going to bring down the minus 35. Okay. Repeat, right? Because this and this are now equal degree. They're both an exponent of 1. So I'm going to repeat. So I'm going to do negative 7x over x. This one's easier. We see our x's cancel and we're left with negative 7. I'm now multiplying that minus 7 times x plus 5. That's negative 7x, right? And minus 35. And then again, my subtraction is really just switching signs. Those cancel. Oh, those cancel too. So this has a remainder of 0. When it has a remainder of 0, we don't do anything. So my answer is whatever on top, 2x minus 7. Okay. Now, this was a much longer way of doing something than I think a lot of you are thinking, couldn't I have just factored this? Yeah, you could have, right? Quadratics are easier, and we started with an easier problem that we actually already learned some form of division when we factor it. If we look at our next example now, however, we have a cubed in there. I don't know how to factor that, okay? So division does come in handy as we get into higher terms. Okay. One thing with example 3, I threw this in here to be a tricky one. If you notice with number 3, there is no x squared. So we must put in 0x squared, okay? It's the same idea as 2055, 56, I want different numbers, is not the same number as 256, right? The 0 is important. And when we do division, it's the same idea. We need a placeholder. Okay, so this 0x squared is like our placeholder. So I'm going to start the same. I have 3x cubed plus x. Sorry, I almost just forgot what I was saying. Plus 0x squared plus x plus 5. So your degrees have to go down. Your exponents. 3, 2, 1, nothing, right? They have to go in that order, and if you don't have one of them, you have to put it in. Leaving enough room up top, and we have x plus 1. Starting this, I'm going to divide 3x cubed by x. I'm still going to have the 3. X cubed divided by x, I have 3 x's, I take away 1, and I have 3x squared. I'm going to line that up with my 3x squared spot. I'm going to multiply this by this whole thing. Three x squared times x is 3x cubed. 3x squared times 1 is 3x squared. Subtracting means changing signs. Cancel. 0x squared minus 3x squared is negative 3x squared. Bring everything else down. Multiply. Or divide, sorry, not multiply. Divide. Negative 3x squared divided by x. Well, again, my negative 3 and x squared divided by x, I'm just going to have 1 x left over. And I'm going to put it right in my minus 3x spots, right? It lines up with all my other x's. Now we multiply. So I have negative 3x times x plus 1. Negative 3x times x is negative 3x squared. Negative 3x times 1 is negative 3x. Subtracting means changing signs. That changes to plus and plus. Negative 3x squared plus 3x squared cancels. X plus 3x is 4x. And then I'm going to bring down the 5. Divide. 4x divided by x. Oh, right, my x's cancel. I'm left with 4. That goes in my nice column of everything that has no x. Multiply 4 times x plus 1. 4x plus 4. Subtract means changing your sign. 5 minus 4 is 1. We don't really have anything else to break down. This is now a smaller degree than x. I can't do 1 divided by x, so I'm done, and this is my remainder. How we write remainders is we add or subtract them on the end, depending if it's positive or negative. This is positive 1. So it'll be plus 1 over whatever we're dividing by. Okay? So it has a remainder of 1, or it's plus 1 over x plus 1. Okay? All right, we're going to do one more example. I know this video is a little long, but this is a longer topic. And then we'll do the last one in class. Okay, same idea here. If we look at this function, it's all mixed up. I'm going to use the same thing. Right? If I have 2056, that is not the same as 6250. Right? If I have numbers out of order, they're not the same thing. So I have to put these in the right order. So I have 4x cubed, then minus 8x squared plus 3x minus 2. And on the outside, we're going to have 2x plus 1. We're going to start by dividing. 4x cubed divided by 2x. 4 divided by 2 is 2. Taking away 1x is just going to be x squared. Putting it over our x squared spot. Multiplying this times this whole thing. 2x squared times 2x plus 1. That's 4x squared. 4x cubed, sorry, plus 2x squared. So I have 4x cubed plus 2x squared. Subtracting means changing signs. Those cancel. Negative 8 minus 2 is negative 10. I'm going to bring down plus 3x minus 2. Then divide. Negative 10x squared divided by 2x. Negative 10 divided by 2 is negative 5. X squared divided by x is x. Multiply. Right, so I'm going to take this this negative 5x, and multiply it by this whole thing of 2x plus 1. I have negative 10x squared minus 5x. Changing signs. Negative 10x squared cancel. 3x plus 5x is 8x. Divide. 8x divided by 2x. 8 divided by 2 is 4. My x's cancel. Multiply. We take that 4 and we multiply it by this. 8x, 4 times 1 is 4. Subtraction means change signs. Negative 6. We move this this remainder goes all the way up. It's minus 6 over 2x plus 1. Right, because it has that remainder. Alright, that is it. Sorry for the longer video. We'll do this last example in class tomorrow, or Tuesday, whenever I see you guys again. Okay? Have a good night. Have a good weekend.